All right, today we're doing section 10.2. We're going to talk about major arcs, minor arcs, semicircles, central angles, arc measure, and arc length. Specifically, what's the difference between these two? Let's see here. Take about 30 seconds, talk with your team, figure out these different measures. 30 seconds, talk with your team. Go. All right, how much is arc AB? Well, BC right here, the measure of the arc is equal to the measure of the central angle. So that's going to be 100 degrees. Arc BC is 100 degrees. How much is arc AB? How much is arc AB? Ms. Williams? 80. 80, correct. It's going to be 80 degrees. Major arc or minor arc, sir?
Minor.
Minor, how do you know?
Because it's less than 180.
Less than 180, and also, how do you know based on just looking at this?
Letters only two.
Only two letters, very good. A, B, D. A, B, all the way around to D. How much is arc A, B, D going to be? Excuse me just a moment. How's that? All right. Okay, measure of arc ABD. ABD. Let's see here.
240.
I'm sorry?
240.
How'd you get that?
180 plus 60.
180 plus 60. Good. 240 degrees. Major, minor, or semicircle?
It's major.
Major. Good. CAD. 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 Mr. Sanders.
CAD.
Mm-hmm. More than 200. Going from C all the way around to A and all the way around to D. You'll notice we're skipping only one part here, aren't we? Well, how many degrees are we skipping?
Just 60.
So how many degrees is that whole thing then?
It's 300.
300. 300 degrees. There's 360 degrees in a circle, 60 degrees left over that we're not using. There you go. AC. AC here. Miss Helvey.
Would it be 180 degrees?
180 degrees. Yes, 180 degrees. It's a semicircle. Now, there's a problem that Michigan did with this. I said AC. That's not telling us which way we're going, is it? So you actually need to use three letters on this. So I should say like ABC or AEC. And arc DE. Arc DE. Tobias?
20 degrees.
20 degrees. How'd you get that?
60 plus, or 60 minus 1.
60 minus what?
Well, 60 plus 20 is 80 plus something, right?
Okay, yeah. These form up, make 180 degrees, semicircle. So that's 20 degrees. Good. It's not up here. How many degrees would arc AE be? AE. Shout it out, everybody. 1, 2, 3.
100.
2 ways you can figure that out. That's 80, or look at these 2 angles. What are they?
Vertical.
They're vertical, so that would be 100 degrees. All right, that's the arc addition postulate. Pretty simple. We've done the segment addition postulate, etc. How many think these are pretty easy? Pretty fun? All right, a review of arc length then. So arc measures how much we're turning. Arc length, we've done this before, is if you're walking around the edge of a circle, how far you would walk. With your teammates, if you need to, look back in your notes here. Arc length is something times something over here. Fraction times the number over here. Let's fill those in. If you need to, look back in your notes. Give me a hand up about that. Give you about a minute to figure that out. Go ahead. Ooh, smart people are looking back in their notes. I like it. How would we set up this formula? Yes, ma'am.
Measure the arc length that you're trying to find over 360 times the circumference.
Yep. The arc measure over 360 times the circumference. So in this case, if you reduce this, for that first, we're going to get 5 over 18 times the circumference. Well, we know how to find circumference, 2 pi r or pi d. So we're going to get, the diameter of this thing would be 12 times pi. And if we want to simplify, we can. Maybe 2 over 3. So 10 pi over 3. And whatever the units are. That's arc length. Let's see here. I need. Okay, ready? Okay. So, arc length is how far you walk around part of a circle. It's a distance. Arc measure is how far you turn around a circle. Turn in a circle. So that's the difference between the two. Any questions over those?